This is Legion, actual 12102017. The disease continues to spread. Many of the crew have become erratic and violent, so I've come down to the basement of the station to work. Let's look at the first problem sheet. Question 2. Body in outer space is in a gravity-free and frictionless environment. It's initially at rest. It's pushed with a constant force. First task is to find the resultant magnitude of the momentum. P. Well, the impulse is equal to the force times time. It's also equal to the change in momentum. So, since the object starts at rest, the change in momentum is equal to the final momentum. So the final momentum is equal to force times time, which is 60 times 0.3, which equals 18. Now obviously, this is newtons times second, so newton second, but momentum isn't measured in newton seconds, it's measured in kilometers per second. Okay, because momentum, another way to calculate it is mass times velocity. And that's exactly what we're going to do for part B. Because if the body has mass 10 kilos, we can find its momentum as mass times velocity is equal to 18. We know that's 10 times velocity equals 18, so divide both sides by 10, and we get that velocity is equal to 1.8 meters per second. Then we need to find the energy, the kinetic energy. Well, kinetic energy is equal to a half mass times velocity squared. So that's going to be a half times 10 times 1.8 squared. I'll let you do the final calculation. Don't forget that the units are going to be joules. Now then, what about accuracy? All the information that we've been given looks like it's to one significant figure. So strictly speaking, we really ought to give our answer to one significant figure. So you could make the argument that the answer to part A is actually 20 kilometers per second. But you could also argue that this is two significant figures, in which case our answer of 18 stands. I'll let you decide what you want to do for part B. Legion out.